During the last few weeks, years of preparation, design, During the last few weeks, years of preparation, design, testing and hard work have accumulated in this impressive site. The 56-meter tall Ariane 6 rocket on its launch pad, all set to light up and soar to space for the first time. As Ariane 6 stands tall on its dedicated launch pad, Tony Tulker-Nielsen, Acting Director of Space Transportation, looks back at a successful campaign.
We started the inaugural flight campaign of Ariane 6 4 months ago. And a campaign like that, of a first flight, you do encounter quite a lot of anomalies. The team has proven very good in solving these anomalies with a focus on maintaining the schedule.
As the launcher itself was put through its paces over the last months, technicians were also getting the payloads, such as the re-entry capsules, ready for flight and putting them on the launcher adapter before placing them on top of Ariane 6. After the passengers were placed at the top of the rocket, technicians performed a wet dress rehearsal, whereby the rocket was filled with over 180 tons of supercooled propellant, well below minus 250 degrees Celsius.
Now that we have done the wet dress rehearsal successfully, we are ready for launch on the 9th of July.
This is, of course, the moment which teams from ESA, France's space agency CNES, and rocket designer and manufacturer Ariane Group have been working towards tirelessly. They will finally see how Ariane 6's engines will be ignited, rumble, and then a roar as the rocket rises from the launch pad and soars towards space, taking less than 10 minutes to reach Earth's orbit and then onwards. Soon, the countdown will begin. Ariane 6 and the teams are on ground, ready for liftoff.
answer in English in few seconds. Just to give you an overview, juste pour vous donner un avant-goût de ce qui va se passer pendant ces quelques heures. Je vais faire donc une très très brève présentation. Alors le lanceur va emporter 8 CubeSats, 2 capsules et 4 expériences scientifiques. La masse totale, c'est 2,6 tonnes qui vont arriver, et le but du jeu, c'est l'orbite visée qui va être à 580 km d'altitude avec une inclinaison de 62 degrés. C'est évidemment le premier vol d'Ariane 6. On est tous évidemment particulièrement à la fois enthousiastes et en même temps avec cette petite tension qui règne dans l'air parce que c'est un premier vol. On aura 3 allumages du moteur de l'étage supérieur qui seront réalisés pendant le vol. Les 2 premiers pour atteindre l'orbite et puis le dernier de quelques secondes pour désorbiter l'étage supérieur. Le total de la mission, ça va durer 2h45 en tenant compte de la passivation, c'est-à-dire la rentrée du dernier étage. On va avoir un réseau de stations au sol qui est réparti partout dans le monde et qui va nous permettre de suivre ce qui se passe exactement. Alors on a quelques coups, il y aura quelques minutes pendant lesquelles à chaque fois on n'aura pas les nouvelles immédiatement de ce qui se passe sur le lanceur. Voilà, c'est justement des moments qui sont... juste peut-être pour vous donner un avant-goût très très rapide. Phase de lancement, on va commencer 7 secondes avant le lancement. Vous allez aller voir le Vulcain qui va s'allumer. À H0, au moment du lancement, vous avez 2 boosters qui vont partir et donc c'est le lancement. 2 minutes 16 secondes plus tard, séparation des boosters. Et après, un peu plus d'une minute après, séparation de la coiffe. Le lanceur sera donc hors atmosphère. Et on aura à 7 minutes le premier allumage du moteur Vinci avec un boost de mise en orbite. Un petit peu après, on va avoir des séquences qui vont nous permettre d'arriver jusqu'au deuxième allumage du Vinci à 56 minutes. Et puis, après, on va larguer donc, les charges utiles. Et donc, à environ 1h06, on aura terminé la phase de lancement à proprement parler. Et donc, ce sera un moment, voilà, c'est un moment qui est très très attendu et qui est un moment très fort. La dernière phase sera une phase de démonstration en orbite. Phase de démonstration technique en orbite où on va pousser au maximum le lanceur, avec évidemment aussi plus de risques, mais aussi plus de mesures de performance. Et tout ça se terminera à 2h40 par la passivation des troupes. Voilà, donc on va vivre un moment qui est un moment assez extraordinaire pour l'Europe spatiale. Je voudrais juste, pour terminer, remercier la Guyane, remercier aussi les forces armées de Guyane qui sont là et qui permettent de sécuriser le lancement. C'est un moment qui est important. On sait tous qu'on est dans un contexte où on a besoin de cette sécurité, on a besoin des forces qui sont autour de nous pour rendre ce moment le plus serein possible. Merci, merci à elle.
So thank you, Philippe, and a very warm welcome also from my side. I'm the Director General of the European Space Agency, Joseph Aschbacher. And I'm very happy and very proud to be here today at this moment of it's a very special moment for all of us, not only in the space community, but also it's very important for future.
Welcome to Europe's spaceport and your front row seat to the launch of Ariane 6.
Le lanceur est juste derrière moi, sur son bâti, et sous la coiffe confortablement installée, les CubeSats et les capsules, prêtes à décoller.
During the next few hours, we will introduce you to this unique rocket, and we will take a look behind the scenes and the teams that made this flight possible.
Et nous serons en direct avec vous, ici, au centre de contrôle Jupiter. Je suis Liz Pedersen.
I'm Tina Büchner da Costa.
Je suis Luce Fabreguet.
And I'm Katie Haswell, and we're all delighted to bring you the live coverage for the first launch of Ariane 6. Operations running smoothly here at the European Spaceport in Amazonian French Guiana, where we're coming to you live as we prepare to turn the next page in space history. Europe's newest rocket, Ariane 6, is on its newly built pad preparing for its first journey into space. We have a stack of passengers on board from experiments and CubeSats. They're up there in the fairing to re-entry capsules waiting to lift off in half an hour. The countdown on the top right-hand side of your screen there. And over in mission control, which is about 15 kilometres from the pad, the nerve centre of operations, the teams inside what we call the fishbowl, that protective glass, are going through the final preparations before launch. Right now the boards are all green. That's a good sign. We are go for launch. I'm in the commentary box here with Tina Büchner da Costa. Tina is a launch systems engineer from the European Space Agency. And in the French commentary box, we've got Lisa Peterson and Luce Fabreguet. Tina, it's great to have you with us. You've been helping to design and test the system, so this is a really big day for you.
Absolutely, Katie. I am so thrilled to be here with you today, and I still can't believe that today is really the day we have all been waiting for. My rocket engineer heart is pumping loads of adrenaline in my system right now, and I can tell you that I share this incredible excitement with all my colleagues who have been working so hard to prepare this moment. It is a great honor to be their voice today, so I really want to shout out a big hello to everyone who worked on Ariane 6 here in Guyana, back in Europe, in the factories and in your homes. This day is your day.
It is indeed, and it's going to take about 3 hours to deliver all our satellites. So just run through what's going to happen, Tina.
Yeah, so earlier today, the mobile gantry, that is the building for the preparation of the rocket, was rolled back, and now Ariane 6 is standing under the Guyanese sky. On top, hidden under the fairing, are the passengers of today's launch. And coming up very shortly is the final countdown. So we will ignite the main engine, followed by this, the opening of the fueling arms. So the yellow ones you see here opening. And just after we're igniting the 2 boosters, we are flying an A62 version with 2 boosters today. We will be heading out northeast on today's trajectory. And once ignited, the boosters provide over 80% of thrust. And after only 2 minutes, they have sent the rocket to about 60 kilometers of altitude using almost 300 tons of fuel. We see here the boosters are separated, and 1.5 minutes later, the rocket is outside of the atmosphere and the fairing that protected the satellites is ejected. Then the main engine cuts off after about 7 minutes into the flight, and the first stage separates, leaving the upper stage on its own. The first ignition takes the rocket to orbit, and after what we call a coasting phase, where we're just doing half a lap around the Earth, there is a second boost, and this will bring Ariane 6 to a circular orbit where our CubeSats will finally be released. So this is a very important moment in today's mission. Here coming up is the CubeSat release in the circular orbit. After that, we will go into a demonstration phase after another very long coasting phase. And this coasting phase is also a crucial part of our mission today, where we prove the novelties of Ariane 6. And at the end of this, the upper stage will flip in space and restart the Vinci engine to brake and set itself on a collision course with Earth, burning up in our atmosphere and limiting space debris. But before it touches atmosphere, 2 capsules are set to detach and head on their own mission to survive the extreme temperatures of the re-entry. And all 3 elements will then splash down in the Pacific Ocean, far away from civilization. This will end our mission.
So that's what's coming up, and here we are now on the pad. Ariane 6. So far, all the tests on Europe's new rocket have been done on the ground, but today it's set to prove itself in space.
Indeed, today is a major step towards the qualification of Ariane 6. With inaugural flight today, the rocket will experience really for the first time its real conditions in space. This is especially true for the...
And you and the teams have been practicing with a test model of Ariane 6. So I wonder how it feels, Tina, to actually have the real thing on the pad today.
Well, you hear my voice vibrating for a reason. It's super exciting, but on the one hand, it somehow feels like a déjà vu, because we have indeed done quite a lot of thorough testing, and we repeat today what we already did several times. We have tested all the systems, and we have, of course, tested the engines on the ground. But this time, when we ignite the boosters, we will have to let our baby go. And I can tell you the concentration and tension among all the teams is quite intense right now.
And Ariane 6 has been designed to carry all kinds of different spacecraft. And of course, the satellites are continually evolving, so versatility has to be the key. What's new on board?
The main change is that Ariane 6 has a reignitable cryogenic upper stage that can switch on and off with the help of another brand new feature, which we call the APU. We will introduce that later. Ariane 6 was built to be modular and flexible, and we can reach several destinations in one flight. It's a bit like a bus that allows its passengers to get out at different stops on request. And today we also have a lot of different passengers on board the bus, and they need to go to different destinations, so we will test that.
Organisations across Europe have come together to build Ariane 6 and guarantee Europe's continued access to space. Let's find out more now about our new rocket, Ariane 6.
Welcome to Lemuro facility, where we integrate the Vulcan 2.1 engine on the main cryogenic stage. Here in Lemuro, we assemble and test the complete lower liquid propulsion module. When the complete module is assembled, we test it, we control it, and then we can ship it to Kourou.
Ariane Group and ESA opted for a very polyvalent, adaptable design for Ariane 6. No compromise on performance and a much broader range of missions.
Ariane 6 is essential for Europe because Ariane 6 guarantees Europe's access to space. And this is what we need because we depend on space every day in our daily life, from navigation to weather forecasts, to connectivity, to agriculture, energy, transport. All of these segments depend on space. That means satellites that we have to bring to space, and that's why we need Ariane 6.
In the conception of the Ariane 6 launch system, ESA played an important role for steering the operational concept of Ariane 6 in a way that reduced drastically the operational cost. This translates in a number of technical choices: horizontal integration of the central core, disconnection of cryogenic arms at the time of the liftoff, brand new concept, very different from the one of Ariane 5.
If you look at the shape, Ariane 5 and Ariane 6 are quite similar. We have a main body, so 5.4 meters. We have strap-on booster. But we have One main difference is the fact that Ariane 6, we have modularity, meaning that we can use 2 or 4 solid rocket boosters.
The upper stage of Ariane 6 is powered by the Vinci engine, capable of 3 reignitions, and is perfectly fitted for deployment of large constellations, execution of complex missions or of ride-sharing.
Une autre innovation de l'ensemble de lancement, c'est le portique mobile, ou plutôt son gigantisme. Il faut avoir des ordres de grandeur à l'esprit. Il est aussi haut que le premier étage de la Tour Eiffel. Il pèse plus lourd que la Tour Eiffel et nous devons être en capacité de le déplacer sur une longueur qui fait à peu près 140 mètres en moins de 20 minutes.
The Ariane 6 launch system is designed for a launch every 2 weeks, enabling us to target up to 11 launches per year.
Ariane 6 will ensure that Europe is on the forefront, continuing the legacy of the Ariane family.
This maiden flight will be the culmination of all this intense work across Europe, and we're looking forward to it. So go Ariane 6, go!
Well, a rocket is nothing without its launch pad, and we've built a whole new launch system for Ariane 6, which really is a massive feat of engineering. But Tina, what do we actually mean by launch system?
So the launch system, Katie, for which ESA is responsible, is actually the combination of the rocket itself and its launch pad. The launcher design and production was the responsibility of Ariane Group and its industrial partners, and the launch pad is designed and built by the French agency CNES and partners, and is significantly different actually from Ariane 5. It has less buildings, less means, and that allows simplified operations and a shorter launch campaign. And the impressive construction, we will see a bit more in a second, was done protecting actually fauna and flora here in Guyane.
And we're looking here now at a movie to show some of the stages. What happened? What are its main features?
So everything started with earthworks and excavation of this 28-meter deep hole. This is where the launch pad now has its flame exhaust ducts. And here we see the start of the railwork for the mobile gantry, so this colossal Eiffel Tower on rails. The building that is used to actually access all the platforms. And you remember, Katie, we've been in there.
Yeah, very impressive.
Floors. Here we see the steel structure actually being built in a time-lapse. And on the left side of the movie here, you see the water tower that is actually used to damp the noise at liftoff. And on the right side, you see the exhaust flame ducts for the boosters. Huge concrete structures, actually.
That's where all the flames of the fire comes out.
Yeah. This here is the assembly building for the 2 stages. Now we do that in horizontal integration, which reduces the cost. And here we see some pictures of the installations for the propellant storage, handling, and transfer. There are thousands of components and valves, and actually a lot more than what we see here is underground. Quite impressive galleries.
Quite a labyrinth under there.
We have a look here at the water pool, which is equipped with the spark igniters. And this is where we burn the hydrogen from the line's cooling process or when it evaporates during filling operations. And here we have a quick look at the water system test. And the water is actually being recycled after every launch. And to finish, we see a mock-up that was used to train putting the rocket in vertical position. And finally, the cherry on the cake for the launch system was the long firing test we did last year in November, where we qualified the main stage flight.
The hot fire test, as it's known. So we have a number of passengers on board the bus today, sharing their ride. All spacecraft, of course. We don't have any people on board. The biggest one is about the size maybe of a satellite dish, and the smallest one is the size of a little box of matches that you could fit in your pocket. We have satellites from commercial companies, space agencies and universities, and they range from established players like NASA to students designing their first ever satellite. And most of them, well, they're testing their technologies, aren't they, to check that they actually work in space, right, Tina?
Yeah, we do have lots of different fascinating small spacecraft on board indeed. Some are detecting gamma ray bursts, so the most powerful explosions in the universe. Some are tracking wildlife. We have one checking which materials actually work best to get rid of heat in space. And one is testing a technology for a kind of a Wi-Fi in space, but using light instead of radio waves. And of course we have two who will return to Earth, so 2 re-entry capsules.
Some really interesting stuff on board there. And we'll be finding out more about them later, of course. But before launch, all eyes are on these status panels. The green panels, that's a good sign, the fact that they are all green. They're showing us the go, no-go status across the base, a little bit like traffic lights. They all need to be green for a launch to go ahead.
Indeed. So what we're looking for are actually 3 main systems. And these panels are showing us the health of those systems. There's the launcher with its ground systems. Maybe it's not very visible on the screen. So we call it the ensemble de lancement and the lanceur. It's on the right side of the panels. Not sure visible for everyone. The second one is actually the satellite, so the so-called payload stack. And then there's a third group that we look out for. They are all part of the range. Now we see it better. The range includes actually telemetry, radars, the weather, and safeguarding. And today we have still a very comfortable launch window. Now it's 3 hours. We had a little delay because some routine checks in the ground segment equipment happened earlier this morning. But it means that there's still plenty of time to fix any glitches if a panel turns red.
And we have a couple of control rooms on the job today. We have mission control, which is what we're looking at, 15 to 20 kilometres from the pad. A bit like the air traffic control tower at the airport. And closer to the pad, we have launch control, a bit more like the cockpit of the plane. Of course, the rocket does go on autopilot after liftoff. Tina, this is your home.
Indeed. This was my home the past month.
You've been there this morning?
Yeah. So this is where we actually get the launch pad and the launcher ready for liftoff. There are 2 teams working here in very close interaction. This is the team doing the actual operations. So these guys are having their hands on the rocket and on the pad, opening the valves, sending in the fuel, switching systems on and off. And next to this room, there's the room for the design authorities, as we call them. So the people who designed the system. Here we have them. This is where I would be sitting. So they see each other and they're separated only by a glass wall. During operations, the designers monitor what is happening in the systems in real time, checking temperatures, pressures, currents, and they see immediately when something looks a little bit unusual or when things go slightly off track. And then they meet and troubleshoot in real time. So this is here what we call on site the bas avant. And they are supported by engineers who actually have the exact same information that we have here in French Guiana, back in Paris, close to Paris. Here they are in Space Code. So all of them belong to the design team in Ariane Group, and they are actually the support office base arrière. It means we can engage more brains to solve trouble if we have some.
The more brains, the better. I wonder how it feels to sit in there, Tina.
It's an absolute dream job.
Right, we have the last weather check coming up. There's our rocket, Ariane 6, standing tall on the pad. We are actually on the Amazonian coast of French Guiana in South America. It's hot, it's humid, it's been raining all morning. The operational teams, they can control a lot of things, can't they, Tina? But not the weather. We're in the lap of the gods.
That is true. We can't control the weather, but we can monitor it. And that's actually very important. Weather conditions must be right for the launch to go ahead. So we always have our eyes on the weather.
And is rain a problem?
Well, it is a problem only for the photographers, not for the rocket. It's not made of sugar.
Well, that's a good job. As I said, it's been raining this morning, otherwise it would have melted. But
Exactly. But there are actually a lot of other things that we need to monitor as safety is paramount here at the base. So several weather checks during the day are made. The first one is made before actually removing the mobile gantry, so that was fine. We rolled back, and early in the chronology, we actually look at the wind on the pad as long as we haven't fueled up. And we're also looking at wind at altitude. So between 10 and 20 kilometers, we look at the wind speed and the directions. We have to guarantee the best conditions for the mission and for safety reasons. And we also look for lightning risk.
Yes, that's important too. And how do we find out about the weather?
So here we see the weather station here in Kourou, and they are launching weather balloons carrying instruments that send back information on atmospheric temperature, pressure, and humidity. And at the same time, we also have sensors around the launch base and at the coast for wind and for lightning. And here we have a look at the launch pad. We can see that we have 4 huge lightning masts, so we are protected on the pad in the case of lightning. But of course, once we lift off, we have to be sure that there's no lightning risk once we head out.
Tina, you've been working here on site for, some weeks, I believe, and some of your colleagues have been here on the base for months, getting ready for today. So I'm guessing that you'll get to know each other pretty well. We call this process of preparing the rocket and the spacecraft the launch campaign, and there are a number of different things that happen during that time. So Tina, just run us through some of the main events of the launch campaign.
So we have a brand new cargo ship, which is called the Canopy. It's a hybrid wind-powered sailing boat, and this one transported the rocket stages from mainland Europe to French Guiana. It was end of February this year. They were transported by road to the spaceport into the final assembly building. So here we do the horizontal assembly of the main and the upper stage, and we also connect the fuel connectors, for example. So what we see here is actually the ULPM. It means the upper stage that is rolled in first, and once we see here both stages being mated. And once this is done, we open the doors towards the launch pad, and we have an automated guidance vehicle that actually rolls completely by its own the 800 meters to launch zone. Then the central core, as we call it, once it's assembled, is lifted up and placed on the table. The boosters, they are actually prepared in a separate booster preparation building, and they are transported on their own transport means, which is a delicate operation because they are already filled, obviously. Once they are then connected to the rocket, we move over to the satellite preparation building that we see here. So here the payload stack is being prepared, and once we actually put on the fairing around all our delicate passengers, we call the product our upper composite. And the upper composite has another dedicated transport mean. Here we see it. It's called the upper composite trailer, and it has ventilations running for the satellites while it's actually being moved over to the launch pad. Yeah, and once the payload stack is on the launcher, as we can see here, the launcher is ready for test or liftoff.
And here it is standing tall there today on the left-hand side of your screen. We're 6 minutes to launch now. We are live at the European Spaceport. The final countdown actually started about 10 hours ago with a lot of important operations. What's been happening, Tina?
Yeah, so at 7 a.m. local time this morning, we had the rollback of the mobile gantry. Since then, we have no more access to the launcher, so we were changing our ventilation systems from air to neutral gas, and we were flushing all remaining humidity out of the system, which is important. And around 9:45 this morning, we started chilling down of the ground lines, and around 11, we actually started filling up the launcher. First the upper stage, then lower stage. Then in parallel we were pressurizing our systems and doing electrical checks, armings, getting telemetry and radars ready. And now we're in a phase that we call the topping up.
À tous de DDO, attention pour la séquence finale lanceur. Top I0 moins 5 minutes.
So our Range Operations Manager, Raymond Boyce, has announced the final 5 minutes of the countdown, a very, very important time. We call it the automatic sequence or the synchronized sequence because Ariane 6 is now becoming progressively autonomous, and there are lots of really, really important operations during this time.
Look at the people there. Here? This is Limero, I think, cheering. Yeah, those operations are actually timed at the millisecond intervals. It's a very impressive list of system checks going on. It's a very exciting moment. So now the controls are actually gradually being handed over from ground to the computers on the launcher. Nobody's moving anymore in the control room because we cannot miss a single operation in this sequence. We stop the topping up, we do a final loading in the tanks, pressurization to flight pressure, we load in the software, we command arming of the safety barriers, and we do the handover. And if anything has to stop, if everything goes wrong in these 5 minutes, we reset the clock back to the 5 minutes.
And here we can see the teams at Ariane Group cheering on Ariane 6.
Everyone is there. And here the teams in Bremen, Moin Bremen. Everyone is here. Awesome. Yeah.
So we are getting close now. Concentration levels very high. A number of things to watch out for as we get closer now to launch, and a few things at launch, and a few changes for people who are familiar with Ariane 5. If you look at the top of the launcher, you can't see them very easily from here, but there's two yellow things clamping on at the top 3/4 of the way up. We call those the cryogenic arms. What's their job, Tina? There's a better shot of them.
Yeah. So we are fueling the rocket with liquid oxygen and hydrogen that we send through these arms, and the propellants actually have to be kept at very low temperatures. Liquid hydrogen at minus 253 degrees, and liquid oxygen at minus 180. And we still lose some of these propellants through evaporation. Right now we cannot really see it because we are in daylight. Otherwise, you would see smoke coming out. So we need to top up the tanks until the last seconds, and we do the exact same thing that we do here on the upper stage, as you can see, also on the lower stage. Here we have the pictures of the lower stage, actually, the fueling system on the lower stage. And so these massive fueling and pressurization systems, they will be disconnected and retracted at liftoff. It's a command that is sent just 300 milliseconds before we send the command to ignite the boosters. And another thing to look out for now, just before liftoff, is that 7 seconds before liftoff, the Vulcan engine will be ignited, and that allows us actually to check it is running smoothly before we ignite the boosters. And once the boosters are switched on, of course, we lift off. There's no holding us back. And another thing that you might see are the plume effects of these boosters. So the extreme heat of the booster waves onto the launch pad need to be managed. And here we have a look at Vulcan, so we will see it firing up in a minute.
This is the main Vulcan engine on the main stage.
Indeed, indeed. And we see here that we are getting a bit lonely in Jupiter too. Everyone is
yes, all the teams
to the terrace.
Everyone going out onto the balcony to watch the launch in real life. We're getting close now, coming up to the 1 minute mark. The range operations manager getting ready to call that out.
À tous de DDO, attention pour moins d'1 minute. Top I0 moins d'1 minute.
We are 1 minute to launch. Our best wishes to all the Ariane 6 teams and everyone who's been working so hard for today. Good luck, everyone.
Go Ariane 6, gute Reise and bon voyage.
À tous de DDO, attention pour le décompte final. 10, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage 2 ESR, décollage. Nominale. Trajectoire nominale.
Europe's new rocket,
Pilotage calme, trajectoire nominale.
Ariane 6, has left the pad and is blazing a trail across the equatorial skies. The range operations manager is telling us that everything is going according to plan. Tina.
And I didn't know my heart can pump so fast. Oh my God.
Trajectoire nominale, pilotage calme.
We're rumbling now. And Jupiter too. We hear her.
It's quite a sight.
Oh, she's coming, she's coming. Oh my gosh. This is happening.
It's the most incredible feeling. We're on the edge of tears here in the commentary box because this is a big day and a big moment.
Trajectoire nominale.
Actually, the building's rumbling around us now. And look, these are the live images from the cameras on board.
We're looking at the booster. We're looking down.
We're looking downwards.
One of the two boosters, we can see the flames coming out of that booster because, of course, the
Positionne la
boosters,
télémesure pour la station de Saint-Jean, propulsion nominale.
boosters are doing all the work. He's telling us that everything is going according to plan and everything is nominal.
And look at the visibility. We might even be
C'est
able
nominal,
to see the
trajectoire
separation.
nominale.
We have clear skies tonight, this afternoon. We had rain all day, but the clouds parted. The two dots there, the boosters.
There we see them falling off.
Séparation des ESR.
Confirmed. We have booster separation. So, wow, that's the first clapping here that we see. What a beautiful liftoff.
And our cameras on board.
Propulsion nominale, trajectoire nominale.
These pictures are coming in with a 20 seconds delay, which is why we have them now. Look at this, how they fall off. Wow. Amazing, amazing. So these boosters, they have transported us 60 kilometers high.
And we can see that dot is
Trajectoire nominale.
telling us that the trajectory is normal, everything going according to plan. That's the engine on the main stage that you can see there. And we've got a camera inside now. What are we looking at here, Tina? Oh, we're looking back down at the Earth.
This was actually a camera inside the interstage, so we will be able to see when the lower stage separates. That's coming up. But now we have actually lost half our mass already because the boosters have burned almost 300 tons of fuel in 2 minutes.
Pilotage calme, trajectoire nominale.
Everything nominal,
And
as
we're
the range
getting-
operations manager says.
Yes, and we're getting close now to the next thing, which will be the jettisoning of the fairing being the nose cone of the launch vehicle, which is where the passengers are sitting.
Séparation de la coiffe.
We even see the... Wow, that's amazing.
We had confirmation there that the fairing has been jettisoned.
Yes, so the fairing that was protecting our spacecraft withstands all the pressure and the heat, and once we stuck out the nose out of the atmosphere, we didn't need her anymore, and it has been jettisoned.
So what we're looking at now is the main stage, which is what we're burning on the right hand of the screen.
Yes, and this is the live camera from orbit, and we see the fairing falling off there.
And
amazing pictures.
You see how it twists? I believe, Tina, that I'm right in saying that's
Trajectoire
what
nominale,
we-
propulsion nominale.
Exactly. And we also see on the screen on the right side actually the telemetry. So on the top you see the trajectory. So in green the planned trajectory, and in yellow the actual flight trajectory, everything going nominal. So you have altitude over time. And in the middle you see our ground track. You see exactly where we are over the Earth. And on the right side you see our altitude. We're already in 140 kilometers.
Trajectoire nominale, il reste moins de 3 minutes de propulsion du Vulcain.
2.4 kilometers per second, and the main stage is operating.
It is, and you can see it here. It's a great big tank of fuel.
Indeed. So it is a 32-meter high cylinder, weighs 23 tons when it's empty, and it can carry 154 tons of cryogenic propellant, supporting the upper stage and the boosters. For our technical audience, we don't have any common bulkhead anymore, so we have now 2 separate tanks. And this makes the handling of the pressures a bit easier than on Ariane 5.
And it's burning a very powerful
Propulsion
engine.
nominale, trajectoire conforme à l'attendu.
He's telling us that the
Everything nominal.
trajectory is normal.
Exactly. Yeah, Vulcan engine is now simplified, mainly for cost reduction reasons with regard to Ariane 5. The nozzle manufacturing is completely different, and the gas generator is made of additive manufacturing.
Il reste moins de 2 minutes de propulsion du Vulcain.
Telling us that there's 2 minutes left of propulsion on the Vulcan engine.
So the Vulcan engine has a new challenge because the booster plumes impact at liftoff. They're actually so high that the thermal protection around the nozzle actually had to be beefed up a bit, and we have tiles now around the nozzle, and the nozzle itself also has a new manufacturing method. So it's a more simple and cost-effective design right now.
We're getting closer now to the next phase, which is switching off the engine and jettisoning the main stage, because of course we want to lose each section of the rocket as we climb higher. The lighter we are, the faster we go. So we're separating the next stage, but that's actually quite a complex process, isn't it?
Indeed, because you have to detect first that the rocket is actually ready for separation. This is done by the guidance algorithm. And afterwards, the Vulcan engine is cut off. And 6 seconds later only, we will see separation of the stage, initiated by pyro commands. And we do that by actually extending a set of springs. And the push that the lower stage does to get rid of the upper stage, or the other way around, to push itself away from the upper stage, has the same push, or the same thrust, as we call it, as the Vinci engine, but it only does that during 0.2 seconds.
Getting close now to what we call MECO, main engine cutoff. That's coming up in a few seconds.
Fin de mission sauvegarde.
Telling us that the safety mission here at the Space Center is now finished. We should be seeing something.
Extinction du moteur Vulcain.
We have confirmation that Vulcan has switched off.
Séparation LLPM.
And the lower stage has separated, so he gets these informations before we can see them on the screen.
So,
allumage du moteur Vinci.
And Vinci was ignited. Wow, that's a very, very, very important moment of this mission. Congrats to Bremen and to Vernon.
And we have applause here.
Clapping here in Jupiter.
Yep, happy faces. The upper stage.
See the lower stage.
Propulsion nominale.
They are on the cameras. Wow. Will we see the Vinci engine also firing up? I don't know if that can be seen on the camera.
Wow, this is really something.
We can see it. Look, look, look. You see the color changing on the Vinci engine?
Yep.
As it's heating up? Beautiful. And you can see that we're actually up there right now.
So you can see that we lifted off from the pad here at the Guyana Space Center, heading northeast, our altitude 373. Traveling at nearly 4 kilometers a second, propulsion normal. And look at that, Tina, the curvature of the Earth with the Vinci engine burning away.
Allumage APU.
And here we hear calling out that the APU, a new feature actually on the Vinci, on the upper stage of Ariane 6, has also switched on. So there's a lot of good news coming in here, because the big innovation actually of Ariane 6 is, of course, the reignitable Vinci engine. It can switch on and switch off, and it does that by the help of the APU.
Pilotage calme, propulsion nominale.
So both are running as planned. We are now in our first Vinci burn phase, and we will reignite the Vinci engine twice in this mission. A big shout out here for the Franco-German cooperation. The upper stage is designed and built by Ariane Group in Bremen in Germany, and the engine was designed in Vernon in France, and the whole stage has been put under test in Lampolshausen on a brand new test bench designed by the German Space Agency, the DLR. And that's
an immense
effort, immense team effort to get this tests done.
So they're all going to be very happy. The first Ariane 6 is off the ground. Let's take a little look now at what's coming up for Europe's launchers in the future.
We are already working with our partners on the significant
significant evolution of Ariane 6 to improve its performance and therefore its competitiveness. It includes evolution of the solid boosters and evolution of the upper stage engine, the Vinci engine.
For institutional customer, we are going to deliver for the European Commission and Niasa for Galileo.
Propulsion
We are
nominale,
going to
trajectoire
deliver
nominale.
for CNES TGA and optical satellite. Regarding our commercial customers, we will deliver for the Kuiper project, and we have 18 launches to deliver for this constellation. And we will also deliver for telecommunication operators such as Eutelsat, Intelsat, and Optus.
Today, what we are doing with our partners is to make a steep industrial ramp-up to increase the production in order to fulfill all the expectations of our customers.
Un des enjeux de la rénovation du CSG, c'est d'être capable d'avoir plus de vols et d'être capable de réduire les délais entre deux vols consécutifs. Et donc c'est pour ça qu'on numérise la base, entre guillemets. Ça va nous permettre de faire ces passages d'un client à l'autre beaucoup plus rapidement. Et ça, c'est un enjeu majeur pour la base, mais aussi pour les clients, parce que ça veut dire qu'ils auront
Propulsion nominale, trajectoire
pour
nominale.
trouver le bon slot pour leur.
In the short term, we are preparing how Ariane 6 can better fit a very quickly evolving market. For instance, with new boosters that have more capabilities. In the midterm, it can be the preparation of such a thing as reusable stages and engines. We are preparing Prometheus and Themis demonstrator.
Ariane 6 will be guaranteeing Europe's independent access to space for decades to come. It will launch missions to the moon, cargo to the surface of the moon, and it will launch our scientific satellites such as Envision to Venus.
The role of ESA will evolve
Acquisition de la télémesure par la
into an
station
anchor
de
customer.
Santa Maria
And this is
aux
quite a
Açores.
paradigm shift for Europe, something that we very proactively pursue is part of my strategy to really change ESA, transform ESA, but also space in Europe. And yes, this is something I'm really looking
Trajectoire
forward to.
nominale.
And here on a hill just outside the Guyana Space Centre is an important group of people inside that building there. We call them the Quick Look Telemetry Team.
Exactly, because all the launch vehicle data are actually sent to the Galileo station, which is so here on site. And the team that we see now here, they don't enjoy the good weather because they're actually the ones analyzing these data in real time, and they are really the first ones to know what is happening on the rocket.
And of course, they send that information, and the range operations manager can then call out those announcements. And our flight path, you can see it on the right of your screen, takes us northeast towards Scotland, over Scandinavia, over Russia, Central Asia, and then back down over Southeast Asia towards Australia. And we've picked up the signal at the Santa Maria tracking station in the Azores. We have that confirmed.
Indeed, so we're controlled by the Azores station now, and this is part of Portugal. So let's shout at Boa noite, Portugal. Thank you for helping us tracking our launcher tonight.
13,000
Pilotage
people
calme,
across
trajectoire
Europe
nominale.
have been
Fin de
involved in
visibilité
creating
par la
Ariane
station
6.
de Saint-Jean-du-Maroni.
And they are proud members of Space Team Europe.
Ariane 6, c'est une épopée. On se sera beaucoup investi, mis beaucoup d'énergie, beaucoup de bonne volonté. Et à la fin, on sera fiers de nous. Je pense que c'est exceptionnel. On n'est pas nombreux finalement dans le monde à pouvoir dire j'ai développé un lanceur. Et c'est vraiment extraordinaire.
Forcément,
Il reste moins de 4
énormément
minutes de propulsion
d'heures de
du
travail,
Vinci.
quelques sacrifices, c'est sûr. Et par contre, ça va laisser surtout des souvenirs d'émotions incroyables, comme lors
Fin
de
de
la
visibilité de la
première
télémesure par la station de
l'attention,
Galileo.
l'émotion qu'on a eue quand la chronologie s'est déroulée. C'est des souvenirs que je suis pas prêt d'oublier.
C'était le 2.1, les opérations que l'on a fait pendant toute la nuit avec cette adrénaline qui nous maintient éveillés, qui nous permet de rester concentrés pendant des heures et des heures sur les opérations que l'on déroule. Donc c'est quelque chose aussi qui qui est vraiment hors du commun par rapport aux autres métiers.
C'était le Covid, on travaillait sous le portique avec les masques, la chaleur, etc. C'était un petit peu l'enfer à cette époque-là, avec les contraintes sanitaires, etc. Mais les gens étaient là, les gens étaient volontaires et c'était incroyable de voir cette énergie malgré toutes les contraintes pour mener ces essais et à la fin les avoir conduits avec les succès qu'on connaît aujourd'hui.
Il est quand même nécessaire d'avoir une cohésion d'équipe importante, d'avoir une entraide entre les différents industriels et les différents spécificateurs et aussi d'avoir quand même une aide de la part de l'ensemble de nos familles parce qu'avec le temps que l'on a passé hors de chez nous, c'est quand même important à dire.
Le bilan que j'en tire de mon expérience Ariane 6 est positif, très positif. Donc il y a eu des moments de doute. Et ce que je retiens personnellement, c'est que même quand on doute, il faut chercher du support auprès des collègues. Il y en a d'autres qui doutent. En fait, on doute tous. On est tous pareils. Il faut avoir confiance en soi. Et ensemble, on peut vraiment aller très loin. Et on le voit avec Ariane 6, c'est qu'on y arrive humainement. Tout est possible.
Je pense que la plus grande fierté qu'on puisse avoir, c'est d'avoir cette équipe, indépendamment même des résultats techniques, qui bien sûr sont à la hauteur de nos attentes. Mais c'est surtout cette belle équipe qui me rend le plus fier. Voilà.
Constitué des différents industriels, différentes personnes, différentes nationalités, Ariane 6, c'est vraiment l'image de le Space Team Europe.
Alors go Ariane 6.
That's your gang, Tina, and your colleagues, right?
Indeed, that really warms my heart, and it's such a pleasure to see these people here. They are, of course, my colleagues, but they have also become friends now, and it really feels like we have become a big family, you know, between Niasa, CNES, Ariane Group, and all the partners, and we have all given so much of our energy, long working hours. We know each other really well right now, and this human adventure that we all share is, I think, what you really feel when you watch this movie, and really. A big cheers to all of them and to all of our families, actually, who supported this incredible time. Because to all this team and to our families, this is where I really want to dedicate.
Il reste moins d'une minute du moteur de l'étage supérieur, Vinci.
So we have 1 more minute before we actually supposed to have cut off of Vinci. And let me use this. They were talking about the adrenaline in the movie, but also what helps our adrenaline and what keeps us up is coffee. So Katie, I have a fun question for you.
Oh dear.
How much coffee do you think was ordered and drunk in the Launch Control Center in the past 2 years where we did early testing and testing of the rocket?
I can only imagine you're going to tell me it's an awful lot.
We have actually done the calculations based on our statistics of orders, and it was 600 kilos in just over 2 years.
Oh my goodness, Tina. You lot drink a lot of coffee.
It's what it takes to move a rocket up.
Human rocket fuel.
We just had the confirmation that Vinci actually cut off. Another big round of clapping here in Jupiter. Congratulations.
Fantastic news.
And we are where we should be at a speed of 7.56 kilometers per second, as you can see here. Everything nominal. 350 kilometers, sorry, of altitude.
And travelling at nearly 8 kilometers per second, ladies and gentlemen, boys and girls, per second. And so that's the first major accomplishment.
L'orbital à l'extinction du Vinci est nominal.
Everything nominal.
Everything nominal. So that's happy faces all round.
Yes, and this is actually where Ariane 5 would stop its mission. We could be now on a transfer orbit to geostationary orbit, but with Ariane 6 we actually plan to take the mission further and reignite the Vinci engine, and this will allow us to travel to a second orbit.
So we're going to be taking a break in a minute because we are scheduled to release our next set of spacecraft about 45 minutes from now, but we've accomplished this first hugely important phase. And look at that, Tina. That's the perspective from the rocket as she flies high in the sky.
We have a beautiful planet that we're looking
We're very,
down
very
to.
lucky, yes. We're going to leave telemetry. We're going to leave the live cams up on the screen for you. We will lose the signal briefly between 24 and 39 minutes. That's perfectly normal. But let's take a look now at the Lego Movie for some ideas of a new set that could be made.
La propulsion est nominale, le pilotage est calme. Fin de la compensation APU. Orbite atteinte à la fin de la compensation APU est normale. Acquisition de la télémesure par la station d'Ossaguel. Fin de visibilité de la télémesure par la station de Santa Maria. Acquisition de la télémesure par le satellite TDRS. Propulsion nominale. Propulsion APU nominale, pilotage calme. Propulsion nominale, pilotage APU nominal. Propulsion APU nominale, pilotage calme. Acquisition de la télémesure par la station de Lucknow. Propulsion APU nominale. Fin de visibilité de la télémesure par la station de Lucknow. Acquisition TDRS. Propulsion APU nominale, pilotage calme.
Welcome back to our live broadcast. Fantastic shots there of Europe's new rocket, Ariane 6, lifting off from her newly built pad here at the European Spaceport. That was 52 minutes ago. I'm Katie Haswell, and I'm in mission control with Tina Buchner da Costa, who is a rocket systems expert from the European Space Agency. Tina, it's so great to have you with us. Thank you.
It's a pleasure to be here.
It was an absolutely incredible launch. Ariane 6 performed like clockwork, and even the clouds parted and gave us clear skies for a beautiful view.
Indeed, it was really a magical moment, and this liftoff just had set this mind-blowing pictures, so I lost everything I wanted to say and just enjoyed the show. I hope you did as well. We could see the separation of the two boosters. We are flying an A62 today, so with two boosters, we could upgrade to an A64 version with Ariane 6. That we actually separated 2 minutes into the flight. Then we saw the fairing opening, revealing our numerous passengers to the environment of space. And a bit less than 8 minutes into the flight, we had separation of the main stage and the first ignition of the novel Vinci engine on the upper stage. The Vinci engine then burned for about 10 minutes, and since then we've been in coasting phase, which will last about 38 minutes. And right now everything is nominal, as we heard also during the break. And soon coming up is the second boost, so the first re-ignition for the Vinci engine. And we were tracked by Lucknow in India, hello India, during the break, and are now getting close to the north coast of Australia, actually.
Indeed, and if anyone who's not familiar with the information on the top of the screen, we've got on the left-hand side the trajectory, that's the planned trajectory, and the white cross is the actual position of the launch vehicle. And then on the right-hand side, you can see our altitude, 550 kilometers above our planet, heading to low Earth orbit. We've travelled nearly 19,000 kilometers if you were to draw a straight line across the Earth from the pad, and Vitesse is our speed, nearly 8 kilometers per second. So we've been coasting without the engine for about half an hour now, but that doesn't actually mean that nothing's happening on board, is it? Because we have a new addition, and you did mention it earlier for Ariane 6, right?
Yes, so you're right. At the moment, the Vinci engine is off. But when we are in coasting phase, the auxiliary propulsion unit, the APU, is actually running, and we heard the DDO saying that it's running nominally, which is very good news. And this piece of equipment is what makes Ariane 6 so versatile, as it is the key to the reignition capability of the Vinci engine, actually. What it does, it uses fuel of the two main tanks and can create a small thrust, a constant thrust, as it has two little thrusters mounted on the rear side of the upper stage. So what does it actually do? We need to manage three things to prepare the reignition. One of the things is the tank pressures. Second thing is the tank temperatures. And we also need to look for the position and the quality of the fuel. And so to illustrate this last point, position of the fuel. The fuels on board, they actually, once we are in orbit, behave exactly like astronauts. They would be floating in space, so they would be floating all around. And this is not exactly what we want them to do, so we need them to stay close to the tank bottom to be able to guide them then towards the engine for reignition. It's a little bit like if you were preventing your champagne glass from spilling while you're running. So this is a bit the job that it actually has
Very
to do.
important thing to be able to
Don't
do.
lose your champagne. So the APU actually creates a little bit of artificial gravity. And the second point I mentioned was about temperature. We need to avoid the propellant evaporating because that would mean a loss in performance. So while the sun is shining on the rocket, it heats up the tanks, and if the propellant then touch the tank walls,
Acquisition d'un télémesure par la station de Niasa.
So we have acquisition of New Niasa in Australia. Hello, Australia. The second job of the APU is actually the tank pressure management.
And this is the scheduled moment here for the switching on of the Vinci engine.
Deuxième allumage Vinci.
Wow. We have confirmation that Vinci has switched back on. That means the APU has also done its second job in repressurizing actually the tanks, which was what I was about to explain. Amazing, amazing. So we could save a lot of helium actually on our upper stage.
Propulsion nominale.
Propulsion's nominal.
Yeah, we could save a lot of helium.
Inspection du moteur Vinci.
Because this is actually done by the APU. Amazing. So that means that we are now in a circular orbit around the Earth at 577 kilometers altitude.
So this is a very big moment and a very important moment. The Vinci engine has switched back on again and off again. And here are the teams. The quick look telemetry guys and girls who we saw earlier on the hill outside the...
L'orbite atteinte à la fin du deuxième boost Vinci est correcte.
Yes, everything is correct as expected after the second Vinci boost.
Outside the Space Center, and they're getting the information in, and they're hearing all those confirmations there. So, gosh, this is a very, very exciting launch, isn't it, Tina? One of the features of Ariane 6 is the flexibility.
APU nominal.
Everything nominal.
Everything nominal.
It's mind-blowing that we got here without any hiccups. This is a great achievement, I can say.
It is indeed, and I was just saying one of the features of Ariane 6 is really having the flexibility, if you like, to deliver any type of satellite to any type of orbit with this engine that can switch on and off. What kind of missions will Ariane 6 be able to deliver?
So Ariane 6 actually will come in two versions. I mentioned it several times. A62, the medium-sized launcher that we're flying today, and Ariane 64, which is more the heavy launcher version of Ariane 6 with 4 boosters. And it is actually designed to adapt to all kinds of mission and all kinds of customer requests. So the flexibility is key here. We have 2 different versions coming also for the fairing, and we will be able to launch all kinds of telecommunication satellites, navigation satellites, Earth observation satellites, scientific satellites, you name it. We can launch constellations in all kinds of sizes and different setups.
Some very exciting missions there, and constellations, of course, are clusters of very small satellites close to Earth, often delivering high-speed broadband. So today we have 17 spacecraft on board. So we have a number of different passengers. Some of them are going to stay on board, and some of them are going to be released in space. The ones staying on board, of course, will be doing experiments. The first batch is going to get off the bus in about 6 minutes. They are CubeSats, which means they're very small cubes, so some of them even as big as a Rubik's Cube. So what's actually going to happen?
Well, 17 passengers, let the picture talk, because otherwise it gets too complicated. What we see here is in green we have the CubeSats. So they are positioned in 90-degree angles in what we call deployers, and they will be released by the deployers very shortly. In yellow, you see the experiments that we have on board, and you mentioned correctly they will stay on board and re-enter together with the Ariane 6 upper stage at the end of the mission, doing their science experiments while we are out there. And in blue, we actually have 2 re-entry capsules that we're going to release in about 1.5 hours' time, because they will actually travel down to Earth on their own, testing re-entry technology. And the CubeSats that we're about to release, they will go out in 3 orders. So we'll send out 3 pyrotechnical orders, and the boxes will open up their doors and release them in our separation altitude that we have right now, which is 580 kilometers, exactly as planned.
So our passengers are going to be testing a range of technologies to see how they work in space. You can see there we're being tracked by the new Niasa tracking station on the right-hand side there. Let's find out a little bit about them now, a bit more about them.
4 satellites will contribute to Earth observation and safety. CubeCat-4 will detect several types of weather phenomena and also analyse land and ice coverage using the reflected signals from global navigation satellites like Galileo. Robusta 3A will measure the accumulation of water vapour over the Mediterranean Sea to forecast extreme rain that could lead to flooding in the south of France. The small OOV cube will track wildlife in remote areas, sending data to scientists in real time. Despite its small dimensions, it has other goals, like testing new perovskite solar cells, a wide-angle camera and an L-band radio system. IST-SAT will help improve aircraft and spacecraft tracking and ultimately air safety by collecting, in space, signals initially designed for use with ground stations. 4 of our passengers will study the mysteries of space science. The NASA Curie CubeSats will measure radio burst emissions from solar eruptions, such as flares and coronal mass ejections that drive space weather. Further into space are gamma ray bursts, the brightest and most extreme explosions in the universe. GRB Beta will be a testbed for a range of new technologies essential for future gamma ray burst detection. Some of our youngest operators are space amateurs, aged from 15 years old. Their PariSat experiment will study black body radiation by finding the best materials to dissipate heat in space. Data on the temperature of its 8 different square plates will be transmitted to the Kiruna ground station in Sweden. Younger still are the high school students who designed Peregrinus to study the correlation between Earth's magnetic field and solar activity, in particular the intensity of X-ray and gamma radiation. The next 5 passengers will develop and test new technologies for the benefit of future rockets, spacecraft and satellites, and ultimately life and infrastructure on Earth. ESA's YP-SAT will record visual data and scientific measurements from Ariane 6's baseplate during the separation of the fairing and deployment of the satellites. Curium-1 will test new open-source hardware and software for the benefit of CubeSat and amateur radio communities.
Manœuvre d'orientation en cours au profit des charges utiles.
Sidlock, our smallest passenger on board, will enable communication between satellites to help make space safer. LiFi, or Life Fidelity, is a wireless communication system that uses light pulses as a data transmitter and could simplify communication between different parts of the rocket. The production of complex structures in space could be a massive asset for space missions, and Replicator will be the first mission to 3D print in open space. Now the 2 deployers. For its first flight on a European launcher, ExoLaunch will deploy 4 of these passengers. And for its first launch ever, Rami will deploy 3 of the CubeSats and will carry with it the handprints of Spanish children who proudly support its mission. Students or professionals, newcomers or established players, these missions all share the incredible experience of flying on Ariane 6's inaugural flight. So, go!
Wow, I'm so impressed to see the science that has actually gone into this and with these small missions, what you can actually do. And it's totally fascinating how young our scientists here are. And imagine what an opportunity to be on this first flight of Ariane 6. Imagine being 15 and being part of all this adventure. It's incredible.
It's wonderful. And a big shout out to you guys as you're watching now, getting ready to see your babies being released into space. Getting close now to the upstages getting ready to deliver our first batch of little spacecraft in just over a minute, our 8 CubeSats.
Exactly. And they, as we said, they sit in the little containers, the deployers, and the doors are still closed. And once they will open, some springs will extend and actually push out our CubeSats into space. So we are crossing fingers for everyone who has a CubeSat, and we'll see space very soon. The upper stage, and we heard that confirmed by the range operations manager, has done the orientation maneuvers that were necessary to be now in the right direction and pointing to where our CubeSats actually need to go. And the APU is switched off in order to avoid that we actually collide with the CubeSats. Very important.
Extinction APU.
Now we have the confirmation. It is actually turned off, the APU. So now our CubeSats are ready to be released.
They're going to be released in 3 waves.
Yeah. First we will see OOV Cube. Bye-bye. Curium-1. Bye-bye. Robusto 3A. And we have initialization of
Début
YP-SAT.
de la séquence de séparation des CubeSats.
And Peregrinus. Second separation was CubeCat-4 IST-SAT. GRB Beta. Initialization of Sidlock and PariSat. And the third one was separation of Curie and Replicator. And since everything happened in 9 seconds, we have the onboard camera here with a certain delay. So here they go. 1. We obviously can't see all the separations because we have only one camera looking up there.
Big cheers and lots of clapping. Very, very happy faces here in the Jupiter control room.
Début de séparation des CubeSats.
And we have confirmation that all of them were actually separated.
It's very
Launch success.
exciting.
Wow, look at this.
I have to tell you that the atmosphere here in the Jupiter Mission Control Center is absolutely electric. People
Actually, no one is in their seat anymore. They're all standing up there.
Yeah, clapping, some whooping, absolutely over the moon.
This is remarkable achievement for all the teams. Hats off to all involved getting this far on the first flight. Congratulations to Ariane Group, CNES, ESA teams, and all the partners involved in all the 13 countries in Europe. This is really something to be proud of. Give your families a huge hug for supporting the tensions and the years of hard work.
Absolutely. Indeed, years of hard work, problems solved, sleepless nights endured, kilos of coffee drunk.
Exactly. A lot of time also without the people who were actually here on site in Kourou preparing this launch, being away from their families. So thanks to everyone out there supporting this.
Absolutely. So we still have 2 more passengers on board, and we are going to be releasing them. They are our 2 re-entry capsules. Tina, do you want to tell us a bit more about those?
Yes, so these capsules, they will actually test the technology for returning to Earth through our planet's atmosphere. And it will take now over an hour and a half to get actually to this next bus stop where we want to release them. And they will be seeing the heat of re-entry once they are released from the upper stage. And we will reignite the Vinci engine once more because we will deorbit and leave no space debris out there. So for sustainability reasons, Ariane 6 is actually designed to clear up the orbit and re-enter after the end of the mission.
Very important. What goes up must come down.
And we actually do come down in the South Pacific, 1,500 kilometers from inhabited areas. So it's the spot with the least populated spot on Earth. Yeah, it's called the Nemo Point, actually.
Aha. So we are now hoping to hear from the directors of European Space Agency, Joseph Aschbacher, Chairman and CEO of the French Space Agency, Philippe Baptiste, who will be speaking probably in French. We'll stay tuned and we'll resume, encapsulate what he said afterwards. Martin Sion, who is the CEO of Ariane Group, and Stéphane Israel, who is the CEO of Ariane Space. They're coming to the floor, hoping to hear from them very shortly.
I see them all in position here. They're standing next to each other, so we can expect to switch over to them very shortly.
They've got thumbs ups. Thumbs up. Lots of clapping.
There we see them. From the left to the right, as they were just called out on the left side, Joseph Aschbacher.
We are looking at some very happy faces here.
Indeed, very happy faces.
Let's cut our mics now and listen to them.
We are ready. We are ready.
So very warm welcome to all of you who are listening here in different establishments, also of course here in Kourou. It is electric here. There's such a good mood. There's such a fantastic feeling here. But let me really just express a few emotions from my side. A big thank you to all of those people who have worked on this launcher. We are making history now. We're making history. We are succeeding. We still have a bit of work to do, just to be very precise, but we have made very important steps. We had the third separation command of the payload. We had the APU, we had the APU firing and cut off. We had the upper stage firing cut off, the Vinci engine. Everything is nominal. Everything is going so well, and this is such a beautiful moment. So thank you, industry. Thank you, task force members. Ariane Group, Ariane Space, CNES, we have been working together with my team of ESA. Everyone has been really giving its best to make this a success. It's a historic day for ESA. It's a historic day for space in Europe. It's a historic day for Europe because this powers up Europe, because we need the data from the satellites that our Ariane rocket will launch in the future. So big thank you, big day to celebrate from our side.
So Joseph has said it all, so I'm not sure I have much more to say, but Europe is back. Europe is back in space, so this is a very important moment. Thank you very much. Thank you, of course, also to French Guiana, to CSJ team, who has been working very, very well and was very challenged over the last few years. So it's a great moment, and Europe is back in space. So thanks a lot.
So good afternoon, good evening in Europe. Today, Ariane is back. And today, with this new launcher, Europe is restoring its autonomous access to space, and we all know how important this is for all of us. But what I would like to share as a feeling is first my sense of relief. It's quite visible after such a success, but also a sense of pride for all the teams who have been working for this program. The thousands of rocket makers from Ariane Group, from all the European industrial partners, from 13 countries who have been working tirelessly on this program to overcome the challenges. It has been a difficult program, and their work enables us today to see such a brilliant success. So I'd like to congratulate all of you, to thank all of you, and really I'm proud of your talent and your dedication. Second topic, because we've got customer here, is that now we have to ramp up production to serve our customers. It is already ongoing, and it starts by a next launch before a year end, and this will be another interesting episode in the saga. And the last topic I'd like to mention is that the mission is not yet completed. The upper stage is still in orbit, maneuvering, and we are expecting a lot of precious information to prepare for the future. So, go Ariane 6, go!
So I want first to thank all the member states who have participated in the funding of the program. We have here former Minister Geneviève Furazo, we have Anna Christmann, space coordinator in Germany, and it would not have been possible without their continuous support. So thanks to all of the member states of ESA who made this success possible. The second thing I want to say is to, as said by Martin, to congratulate all teams. This decision has been made since a decade, and all teams who have worked for this success in the agencies, in industry, is an outstanding Team Europe, and today it is their success, and they must be very proud of what they have achieved. And last but not least, it's our customers.
Allumage APU.
During these years, the customers stand on our side. We have a backlog of 29 launches to deliver for both institutional and commercial customers. It would not have been possible without their trust and without their loyalty to Arianespace. So my thought now is going to our customers who have been on our side, and now we must deliver. And I am very proud to announce that what has been achieved since 1 hour and 6 minutes and what is currently being achieved allows us to make a mission for the French MOD by the end of the year, and it would be the second mission of Ariane 6 and the first operational mission. Thank you very much.
So, Europe is back, powered by its new rocket, Ariane 6. Congratulations to all the teams.
You can really see the relief here and the recognition for the teams. And I'm very happy that the big bosses share this, actually, because the team effort that has gone into this was simply amazing. And I think they they expressed it very well. Now you see more and more happy faces, and they're turning in all directions to congratulate each other. What we heard also calling out, the range operations manager said that the APU actually already switched on again. This is, let me call it, another major achievement. And there are many more to come in the ongoing coasting phase. I don't find words to count the major milestones anymore that we could have achieved here today. It's mind-blowing.
It's fantastic. So we are going to take now a break because our next passengers are going to be released in about an hour and 25 minutes before we get to the next bus stop to release them into space. So we're going to take a little break now for about an hour and 20 minutes. And during that time, our rocket's going to do nearly a lap of the Earth.
Yeah, and while it's doing this lap of the Earth, it's actually doing a lot in the so-called demonstration phase. So this is a very important phase that we won't comment on right now, but this is a very important phase for the qualification of Ariane 6. And
quick word on what's going to happen in the last section.
Indeed. So don't miss this last part of the mission, because the return to Earth and splash into the Pacific Ocean of both Ariane 6 and the two capsules will be an important moment.
And we are going to have a replay of that fantastic launch. Join us after that in an hour and 20 minutes to find out about the mysteries of Space Case
and Bikini.
Now watch the replays.
À tous de DDO, un peu de calme s'il vous plaît. La mission n'est pas finie.